Let's quickly understand how to calculate the diffusion rate for the steady state diffusion of A through non-diffusing B. Here is the question. Oxygen is diffusing through carbon monoxide under steady state conditions with the carbon monoxide non-diffusing, which means that this problem is based on the condition where oxygen diffuses through the non-diffusing carbon monoxide. That's why here oxygen is component A and carbon monoxide is component B. Then we have given the total pressure as 1 into 10 raised to 5 Newton per meter square and the temperature 0 degrees Celsius. Which means that we have given capital P is equal to 1 into 10 raised to 5 in Newton per meter square. And T is equal to 0 degrees Celsius, which can be written in Kelvin as 273. Then we have given the partial pressure of oxygen at two planes 2 millimeters apart is respectively 13,000 and 6,500 Newton per meter square. Which means that we have given Z is equal to 2 millimeters, that is 0.002 meters. Then PA1, which is the partial pressure of oxygen at one end, is equal to 13,000 Newton per meter square. And PA2, which is the partial pressure of oxygen at another end, is equal to 6,500 Newton per meter square. Then we have given the diffusivity for the mixture is 1.87 into 10 raised to minus 5 meters square per second. Which means that D is equal to 1.87 into 10 raised to the minus 5 meters square per second. Then we have to calculate the rate of diffusion of oxygen in kilomole per second through each square meter of the two planes. Which means that we have to calculate Na. So to calculate the rate of diffusion of oxygen in kilomole per second through each square meter, that is Na, for steady state diffusion of A through non-diffusing B, we have the formula. Na is equal to DAB into P divided by RTZ PBM into PA1 minus PA2, where PBM is the log mean partial pressure of component B and is given by PBM is equal to PB2 minus PB1 divided by ln of PB2 divided by PB1. Now if you look at both formulas, we can say that to calculate Na, we first need to calculate PBM. And to calculate PBM, we have to first calculate PB1 and PB2. So now, first let's calculate PB1 and PB2. So the formula for PB1 is P minus PA1. Hence after putting the value of P and PA1, which is already given, and solving it we get PB1 is equal to 87 into 10 raised to 3 Newton per meter square. Similarly, PB2 is calculated as. Hence we get PB2 is equal to 93.5 into 10 raised to 3 Newton per meter square. Then after putting the value of PB1 and PB2 in the formula of PBM and solving it we get PBM is equal to 90,200 Newton per meter square. Now let's put all the values in the formula of Na. Then solving it we get Na is equal to 2.97 into 10 raised to minus 5 kilomole per meter square second. In this way we get rate of diffusion of oxygen in kilomole per second through each square meter of the two planes as 2.97 into 10 raised to minus 5 kilomole per meter square second.